side. Okay. So, doing a talk on blackholing the internet, and the majority of this is a live demo, and so, disclaimer, I've not videoed this at all, so this could go horribly wrong, but hopefully it should be okay. So I've tested it a few times, it should be alright.
I bought the demo on card on eBay.
Did you? Cheers, man, that's good. This is me. I'm a third year ethical student here. I do web stuff. Just a lot of web coding, web hacking. Kind of cool. One of those weird artist, music-y people as well. And right now I'm sort of looking on building Internet of Things devices with a web server backend and then connecting that to actual devices using small sort of Raspberry Pis, Arduinos, that sort of thing, connecting them to devices that wouldn't otherwise be IoT connected. But that's totally different to what we're doing today. So. And that's me, I'll climb a mountain just as well. Who knows what BGP is? Hands up. Yep. Who's configured BGP routers before? That's good. I like that. That's good. Cool. So it stands for Border Gateway Protocol, and basically it stands on the edge of a network. So the internet is made up of things called autonomous systems, and these autonomous systems are big blocks of the internet, like our internet service providers, or universities, or people who have control of large blocks of IP addresses. So typically you would announce prefixes that you manage. The prefix being obviously the specific number 192.168.0.0 /24 would be a subnet mask. So you would advertise the IP prefix alongside an AS path. And the AS path is the number of hops to go from the origin, which is yourself who's advertising the prefix, to whoever's requesting the data. So, for example, if I was serving the Abate website, say for example, Abate had an AS, it would go through from Abate's AS to probably maybe Virgin Media, where that would be taken, and maybe if you're on BT, be across to BT, and then you would have that your AS path would made up these numbers, telling you which autonomous system is passing through and how to get there. So, yeah, you'd have the AS path in the prefix. This is also to avoid loops, and this prevents you from ending up in a BGP in a routing loop. Or you could of course just not advertise your own and pretend to advertise one that you actually don't own, so someone else's. So the win condition for BGP. So this determines how you will connect to an IP address. So if you connect to, say, one advertisement as opposed to connecting to a different advertisement. So for the same length prefix, if you've got 2/24 networks, so if you've got 192.168.00/24 and another one /24, exactly the same prefix, the shortest AS path will win. So the shortest distance to that place will win. For different length prefixes, so for example, if I've got a /24 network and a /25 network, the /25 will always win because it's more specific. So the more specific prefix always wins regardless of the route, most of the time. So how does this tie in with internet service providers? So you'd imagine, I sort of mentioned also before, BT would tell Virgin about its customers that it announces for. So they'll take care of certain IP ranges and blocks, and then they will advertise those prefixes on behalf of other customers, so the internet can connect to that range. In America, it'd be the same. Verizon would tell Sprint about their customers, and the other way around. And you'd have these links on the edge routers of each of these ISPs, BGP, external BGP routers, and they'd be peered with each other, so they'd be BGP neighbors. And all the updates that go through these links are shared via BGP update messages. Have a look at those in a second. So updates from customers are passed through to their upstream provider. So if I have Virgin manage my small IP range that I might have, I would advertise my routes up to Virgin, and then they would take it, and then they would pass it on to BT, they would pass it on to Verizon, Sprint, to wherever, so that it gets propagated throughout the internet. The best thing about this is it's all trust-based. So I go, hey Virgin, I have this IP block. It's mine. So can you announce that for me? And Virgin goes, sure. There's no verification at any point. Just goes, that seems okay. I can do that for you. There's no public key infrastructure, no validation, just on a handshake. Yeah, sure. That's my IP range. So how do we get IP addresses in the first place? And I'm sure that most of you pretty much know this already, but I'll just skim through it anyway. So ICANN assigns IP blocks to RIRs, which are regional internet registries, like RN right in the EU, RN in the US. I actually got that written down there. And they'll assign /8s to these regional internet registries. And then the internet RIRs will then distribute smaller blocks out to ISPs. So that's sort of the chain of command of IP allocation. It goes ICANN /8s, and then RIRs down to ISPs with smaller blocks, incremental. Another thing to note about this is that these IP addresses that are given from ICANN or from RIRs are not assigned to AS numbers. So Virgin Media would have say they have an AS of 10, and they have an IP range of like, I don't know, say 10, a 10/8 and a 24/8. They have that range. That's not then assigned to Virgin Media's ASN, which is the AS number. So there's quite a lot of implementation errors in the wild for BGP. So if I was to advertise a route up to Virgin saying, hey, I own this, there's often not a lot of filtering, because I'm paying as a customer for them to advertise my routes, and so they don't want to have the hassle of bad complaints, bad feedback from customers, or people are paying a lot of money for the service. So they tend to have minimal filtering on the upstream edge router. The sort of minor filtering they might do is rate limiting, so they don't want you to throw up 200,000 routes and flood their table, their routing table. So they'll rate limit how much you can put up. But other than that, they tend to just push up updates that you originate. And they also tend to only allow you to put routes up that are originating from you. So if the AS path that you're sending is longer than just your AS number, they tend to block that out and just forget about it. So they only advertise ones that you originate yourself. Another great thing is no local filtering on networks. So private networks, internal networks, if you advertise in a certain area that you're using only internally, and then if someone else was to advertise a more specific route to this internal network that was not otherwise internet facing, sometimes these internal networks go, oh hey, I found that IP address for that computer that you're trying to talk to, I found it on the internet, so I'll go and send that data over the internet. So instead of keeping it internal, you suddenly have a data leak going out to the internet. So yeah, BGP propagation out from the internal network out to the internet. And another key thing to kind of keep in mind as well is once you hit like a backbone X, like a big ISPs, across ISPs, you just sort it because they will propagate because they trust each other like implicitly. Because otherwise, there's no point. Real world examples of this. I don't know if anyone remembers, possibly quite a while ago now, the AS 7007 when the whole of the internet basically went down because the guys who owned this router accidentally leaked a whole lot of routes that they weren't supposed to from their internal network out into BGP, and it got pushed out, and then everyone started trying to connect to AS7007, and obviously it wasn't being served, it wasn't serving anything, and so it was all dead. It all totally went down. That was in 1997 or something like that. Spawning unassigned blocks. So there's a number of /8s on the internet that are just unassigned. And it used to be a case where spammers would use this range, they would advertise a range so that they can use these IP addresses and spam out loads of spam emails or whatever, lots of data that couldn't be assigned back to them because they were just saying, hey, I own this bit of the internet. But it's unassigned, so who's using it? I'll use it. A more recent one, YouTube Pakistan. I don't know if anyone remembers this. YouTube. So Pakistan decided, oh hey, YouTube's quite bad. You know, it tells people can find information on that. So tell you what, why don't we shut that down? Because we don't want people getting YouTube in Pakistan. The problem is, Google announced five routes to YouTube. They announced /19, 20, 22, and 224s. So what Pakistan go and do is they go, oh yeah, okay, we'll just block some of these IP addresses. So they go and throw up a really specific /22 network that goes exactly to the point that that YouTube points at. So this is like the CDN for YouTube that holds all the data files, all the routes in from that. And they just point this /22 at 0 in the router. So it just kills all the traffic. So it comes into the Pakistan router, and Pakistan go, no, you're not getting that. Just going to delete that traffic. The problem is that ends up in BGP, and suddenly that route to 0 in Pakistan is across the entire internet. It gets taken up by PCCW, which is a Hong Kong ISP, who don't filter at all. So they just take up Pakistan's assignment and then pass it down across the whole internet. And YouTube goes down for 5 minutes, during which time I imagine there are some engineers from Google frantically on the phone to many ISPs going, please delete that route now. Like do it now. Another one more recently, a hacking team and the Italian police. The Italian police were following a whole load of IP addresses and PCs for a while, and suddenly they went black and they couldn't contact them because they were under Aruba SPA, which is an ISP that was supposed to be bulletproof, and you can't get past us because we are criminals. Is effectively what they say. And so the Italian police teamed up with hacking team, the hacking team called Hacking Team, and said, well, I'll tell you what, why don't we just announce routes for the IP block that we can't contact anymore? And so what happened here is they announced these routes, and suddenly all these computers come online again, but they're going through Hacking Team and Italian police. So they're going through man in the middle and then back again. So they've now got access to these computers through a BGP propagation message. Is that a question? Or?
Sorry. Is that illegal, what they did?
You know, this is a funny thing as well, because no one really knows if it's illegal or not. Because was it an accident, in inverted commas? You know, a lot of these ones where I say 7007 was an accident. Genuinely was an accident. There was an email went up on the mailing list saying, oh, sorry, I made a mistake, guys, this is my bad. But this one, it's the first time that there's been that big a sort of controversy over BGP updates, because it's really breaking the trust that the internet is built up on by doing exactly what they did. Everyone kind of went up in arms about it. You can't do that, that's not okay. But they're not going to get arrested because they're the police. Another one was Bitcoin stealing. Some guy was grabbing routes for 30 seconds at a time from Bitcoin miners in a pool, right at the point where they were going to get the payout. So he was waiting for the guys to do all these hard work, and then on the last 30 seconds, he'd grab the route, get the Bitcoin, and then ditch the route. And so he was getting all this Bitcoin for no work. It's great. Well, not great, it's really bad. But it's really cool, interesting. So that was another one. I think they fixed it somehow, but I can't remember how, and yeah. Okay, so demo time. So that's my network I've set up. I'm just going to quickly talk through it. We've got an attacking system here. So this is a standard web server that's just going to serve the Securi-Tay website, just locally. And here's the guy trying to connect to it. This is Autonomous System 20. And we're going to try and, actually no, first off, we'll just try and do this one, which is the AS50 is just going to serve a page that says, hi, I'm an AS50 server. And then we're going to try and force it to go to this attacking AS rather than the actual properly originating AS over there. I'll just turn the servers on. That was password, by the way. So was that one. Can everyone see the screens at the back, by the way? Can you read all that? Is it good? Yes. So okay, so just nice. So this is the client, and what I've done just so it looks a bit better, it kind of makes more sense. I've just gone and thrown up two entries in the hosts file, which I'm just going to share right now, just so you can see. Just so these IP addresses resolve to securi.com and Securi-Tay. Just so you can see that when you type that in, this is what would happen if it was on the wider internet, but this will always be in routing tables on the internet, not just hosts file. Demo doesn't do that like that. Oh. 2 seconds, guys. I'm just going to connect to the routers now. And we've got router 10, 20 and 30, so we'll just connect to 10, 20 and 30. So there's the routes that we probably get across PGP. So you can see there's a 10/24, which says the next hop is the AS10 router. 1 to 20, which is the internal network. And then 1 across to the AS50, which is the other router as well. Was working literally 5 minutes ago, as always. So just have a quick look at the AS10. Get hold of that one. Right, so I'll tell you what I'm going to do is walk you through what I would have done, right? And then we'll try and fix it in a second. So, what happens is you would set up on your router this one here. So this one's advertising a 100.10.0.0 with a mask of /24 mask and 255.255.255.0. If I wanted to feed it and put it on this one, I would advertise a /25. And because it's the same path, same distance, this router here would favor this route here because it's got a more specific prefix. So in the case of this one, if I'm running the same length mask, then what you can do instead is, because it's a shorter distance from here to here, even though you're advertising the same length mask, it will still favor the shorter route because it will have less jumps in the AS path, so it'll be quicker, supposedly, to get to that target. I'm just going to quickly go back and just finish off what I've got here, and then we can have a little another go at that. Don't quite know why that's not working. So the question is, okay, sure, you can take this traffic from another router, but can we man in the middle this attack? And the answer is yes. Yeah, we really can. And the problem we encounter is that we need to serve the real website. So if I'm taking traffic from somewhere else, how do I then serve the website? If I propagate the route that I am the website, how do I get out of that? Because everything's going to point back at me. So how am I going to get out past that stage and get back in again? So the answer is to use ASPath ASN prefixing, which sounds complex. All it is just throwing the AS numbers into the AS path for the true route. So if we look at this diagram here, if this is a client, AS700, AS600 is serving the real website, and this is me, AS500. I want to keep my own route open so that I can still access it, but break this route. So you can see that AS700 would first jump to AS20. Sorry, AS600 is announcing a /24 as well. And it would move through and find a route like that. For example, that might be the shortest path to get there. And then I go ahead and... Oh yeah, sorry, all of them are connecting. Yeah, cool. And then that's my route finding connected there as well. Then I go ahead and announce a /25. But I put the AS10 and AS40 inside the AS path. So my path could have been anything else, any other route, but I'm going to force it to have this 10 and 40 inside the path. So what happens then is, because mine's more specific, AS60 will swap. And then it'll propagate that route further. So AS20 will swap. AS700 will take that route from 20. And then that'll propagate it even further when there is a more specific prefix. And same when that passes through to AS50. And now we can't see the bit I was going to do because this has popped up. Anyone have to fix that? Anyone?
Is the connection back to
Not sure. Anyway, I'll work underneath it. You saw what it was before. So basically the red route now comes through and hits my server. But because I've not broken my route, I still have access to this route. What I'll do is I'll nail up a static route for this IP address, pointing at AS10. So it comes into me, and I go, okay, sure, I know what that is. That's over at AS10. But then AS10 will take it and go, no, I've got the BGP route, it takes it to here. And because it's not been taken, because if you put the AS path inside the BGP update, the routers that have that AS number won't take the BGP update. They'll go, oh, I'm in that, I don't need that. Oh, that's me, I don't need that. So yeah, hijacking the AS path, he prepends the AS path with the correct route, right down to the originating OS. So you'll include the old server as well, the correct server. So in the example of that, so it might be used on the terminal on Cisco iOS. Set AS path prepend 1040 600. and then you set a static route towards crypto. So that's just routes towards AS10. Are there any mitigations for this? At the moment, your best bet is just to know someone at the ISP. And call them and go, that needs fixing. Someone said on the internet that route flapping, which is the process of turning your BGP edge routers on and off in quick succession, might help to alleviate incorrect routes. But it was kind of proven to be a bit of a fluke because that shouldn't happen, because if you're flapping a route on BGP, you're less likely to be accepted. So he was going on about, oh yeah, you can do this, and it will help get your route back, it'll help stabilize the routes. I'm not convinced that that's all true. But I could be wrong. If anyone knows at all if that's right, then yeah, but I think it's kind of maybe a bit lucky that worked. Yeah, it's very ineffective. There have been a number of secure alternatives suggested, such as secure BGP, pretty secure BGP, and secure origin BGP as well. So basically these add encryption to the edge routers. So what will happen is it'll introduce HMAC to prevent tampering in flight. Well, that in itself is unlikely anyway, because your in-flight transmission goes from edge router to edge router and nothing in between. It's a 2 ISP. So if you've got that, you're kind of screwed anyway. What it does add is PKI and certs. So what you're going to add is assign a public key to an entity certificate. An entity certificate basically says, oh, I am this AS, I do have access to this autonomous systems. And then what they use after that is auth certificates to bind the AS number to the IP range. So you can have a number of IP auth certificates, because that will give you multiple routes, which is possibly what you need sometimes. But you'll still have an entity certificate saying, I'm the autonomous system. Mitigations, for the mitigations. Uptake. These were all announced a long time ago. They've been in development for ages, but I have 4 words that kind of really describe what it's like trying to push this out, and they're just simply Internet Protocol version 6. It's about as useful trying to put that into the internet as it is trying to put secure BGP. No one wants to do it because no one wants to pay for it. No one wants to have all the work to do that. And so really, people are going, well, it works, so why change it? Well, it doesn't really work, but it's okay. That's sort of all I have. Does anyone have any questions before I try and maybe have a go at demo? Maybe. Any questions?